Right, for week 9, we are looking at absolute value equations. We are also going to look at absolute value inequalities. We're going to do them separately, and also we're going to focus first on just doing one variable, then we'll work up into 2. So let's get started here. Now, we've seen absolute value things before, so if I say something like the absolute value of x equals 5, it should be pretty obvious or come pretty natural to us that we would know, well, there's supposed to be 2 answers there, right? It could be either positive 5 or else it could be negative 5. Both of these answers, if you plug them in, the absolute value of positive 5 or the absolute value of negative 5, both of those will equal 5. So one property of absolute value equations that I want you to know is, for the most part, there will always be 2 answers. The only time when there wouldn't be is if we look at something like this. If we have absolute value of x equals negative 7, well, in this case there should be no answers, because an absolute value cannot be a negative, right? So an absolute value equaling a negative, there will be no answers to that. The only time there would be one answer is if we had an absolute value equal to 0, because then it's only 0. That's the only time it works out for one answer to be possible. Okay, so let's move on with that. When there are operations outside of your absolute value bars, we treat the expression or the equation pretty much just like we would an equation. So for example, if we're looking at the absolute value of x plus 4 equals 9. So some value right here, I'm going to put a little circle around this piece. Some value plus 4 equals 9. Well, we can use our ideas of equations to say, all right, well, if I just subtract 4 from both sides, it's like saying some value, whatever was right here, equals 5. So remember that some value was an absolute value. So absolute value of x equals 5. All we did was just subtract 4 from either side. So again, we basically just treated it like an equation. Once we get here, this is just like we saw before. There should be 2 answers. So we would say, in this case, x is either positive 5 or negative 5. Those are the 2 answers. Okay, similarly to how we treated this one like an equation, we're going to do the same thing here. Since this times 2 is outside of the absolute value bars, this is saying 2 times the absolute value of x equals 12. Well, we just divide both sides by 2 and it get absolute value of x has to equal 6, right? Something in here, when we take the absolute value of it, times 2 will equal 12. So get this whole piece alone, dividing by 2 on both sides, absolute value of x equals 6. So again, we should be able to see, all right, it's either positive 6 or negative 6. So we always treat them like equations. And the big deal here is we're trying to get this piece, this absolute value of x, alone. This is the chunk we want alone, just this piece. Okay, notice that this one was connected to a 2. That's just saying we're doing 2 times this. You can't distribute it because the absolute value keeps everything just positive. So we don't distribute, we get rid of this coefficient, we get rid of this little factor of 2 by dividing both sides. That way it just says absolute value of x equals 6, and then we can go from there. Working with absolute values when there are multiple operations outside. So again, if we want to get this piece alone, notice there are a couple different operations here. We're timesing by 2 and then we're adding 3. So again, we just treat them like we would any other equation. We work backwards and get this piece all alone. So if we want to get this absolute value of x alone, yes, you might say, okay, we need to divide by 2. You can do it that way if you want, but then remember you have to divide by 2 correctly. You'd have to divide this by 2, this by 2, and this by 2. So then you'd have absolute value of x plus 3 halves equals 13 halves. Then you'd have a lot of fractions to deal with. You can totally do it that way if you want. I would suggest subtracting the 3 from both sides. Minus 3 here, minus 3 here. We get 2 times the absolute value of x equals 10. Now go back and do that divide by 2. absolute value of x equals 5. Okay, so we could do the divide by 2 first. Probably easier just to do minus 3 first. That way we get to absolute value of x equals 5. We have our absolute value piece alone, just like we were looking for. So now we can split it up and say x is either positive 5 or negative 5. Let's look at another one. Again, we're trying to get this piece alone. We could definitely do this divide by negative 2, but we have to do it to each piece correctly. So instead of dealing with those fractions, let's add this 3 on. So we add 3 to both sides, we get negative 2 times the absolute value of x equals negative 4. Now you might be tempted to say at this point, oh, absolute value equals a negative. There's no solution for this one. But actually there is. We can't say there's no solution until this piece, the absolute value piece, is alone. Okay, so we still have to do divide by negative 2 on both sides, and we get absolute value of x equals 2. So then x is either positive 2 or negative 2. Again, the trick here is getting the absolute value piece alone. Once that's alone, then you can split it into your two answers. Now, what do you do when there are operations inside of our absolute value bars, like this one? Now, obviously, it would make a lot of sense to say, okay, this whole thing equals 5, so if it was just x, then x equals positive 5 or negative 5. But we've got an extra little plus 3 here. So obviously it can't be just 5 and negative 5. That's not going to work out here. So we think of just this piece, just this x plus 3, as y. I'm using a totally different variable here. Okay, I'm basically replacing this with y. If I did that, then it would say absolute value of y equals 5. So then it would be totally alone. So once this is alone, it makes sense to say, all right, let's split it up into y equals positive 5 or y equals negative 5. Okay? Well, remember, it wasn't actually y that's under here. We need to replace it back with that x plus 3. So we can split it up and get x plus 3 equals 5 or x plus 3 equals negative 5. All we did was take these answers and then replace that x plus 3 back in. Okay? So, again, that's just kind of a way to think about how it works. I don't want you to go through all of these steps every single time. Okay? That should just help you make sense of why we do this or what just happened. Really, what happened was that x plus 3 is here and here. Okay, everything that's underneath or inside the absolute value stays. X plus 3 is still x plus 3. It's still x plus 3. It's the other side that changed. So instead of being equals of 5, this piece, one of them still has equals 5. One of them has equals a negative 5. Okay, so we change it. We split it into two equations, one where it's still positive, one where it is a negative. Now that we have it split into two, subtract the 3, we get x equals 2. Subtract the 3 over here, we get x equals negative 8. So we would say these are our answers, x equals 2 or x equals negative 8. Now, just to double check, let's make sure those actually work. Plug them back in for x right here. 2 plus 3 is 5. Absolute value of 5 is 5. So that one works, meaning positive 2 checks out. Let's try it with negative 8. If we plugged in negative 8 right here, plus the 3 makes a negative 5. Absolute value of negative 5 is 5, so this negative 8 checks out. So the trick with absolute value equations that have operations inside, like this, inside of our absolute values, is we're going to split them. Once this is alone, we split them into a positive version and a negative version. So in solving absolute value equations, the trick is this part right here. If you have an equation that has something outside times your absolute value plus something else equals something. Okay, I know there's a lot of somethings there, but you might have equations that look something like this. You're always trying to get this part alone. Once it is alone, then you split it into two different equations. One where it's just this part, and notice there's no more absolute value bars. It's just this part alone equals a positive answer, and just this part alone equals a negative answer. Then you solve it. So let's do one more example. This time we're going to see an example of our absolute value equation that has variables on both sides. So notice, here's an x on this side in our absolute value, and here's an x on this side not in the absolute value. Okay, so while we are solving this, we're going to treat it just like a regular equation and try to get all the x's to one side, all the y's to the other side. But first, before we can do that, we need to get this piece alone. So to get this piece alone, first we're going to start by adding that 5 to both sides. So add 5, add 5. It's now 3 times the absolute value of 4x plus 1 equals 6x plus 9 instead of plus 4. Next, we're going to divide both sides by 3 to get rid of this piece. So again, remember you have to divide the entire side by 3. So that goes away and just leaves our absolute value. This entire side divided by 3, you have to kind of distribute the divide by 3 to each term separately. So 6x divided by 3 is 2x, 9 divided by 3 is 3. Now, at this point, we're ready to split. We have our absolute value piece alone, so we split it into two separate equations. One where this piece was exactly the same, it's still positive. One where this whole thing is negative. So I want to show you what I mean by that. If we take this whole thing in parentheses and say that it is negative, this negative has to get distributed here and here. So it's the entire side that's being negative. That's why it's negative 2x and negative 3, or minus 3. So we split it up into two sides, one with a positive, one with a negative. Now we just solve like a normal equation. So over here we would say, oops, let's get rid of that, minus the 2x from both sides and get 2x plus 1 equals 3. Minus the 1 from both sides, get 2x equals 2. Divide by 2 on both sides and get x equals 1. On this side, we're going to do something very similar. Over here we got rid of this 2x. We're going to do the same thing. We're going to get rid of this negative 2x. We're going to add 2x to both sides. So it's 6x plus 1 equals negative 3. We're still going to subtract the 1 from both sides, so we get to a negative 4. Divide by the 6 on both sides, and we get x equals negative 4/6. Or we can reduce it and say negative 2/3. So in the end, our answer is 1 or negative 2/3. So again, we start with our original equation. We're trying to get our absolute value piece alone. Once it is alone, that's when we split and we solve each of those separately. And we have one combined answer. Now, one last thing I want you to be aware of is we always need to be double checking our answer by plugging it back into the equation. And I'll show you why in this case. So on this one, I purposely made no more stuff on the outside of this, so this one is ready to split up. So we split our equation into two separate pieces. Notice, no more absolute value bars on either of these. Notice this side, everything is opposite. Instead of positive 2x, it's negative 2x. Instead of negative 3 or the minus 3, this is now plus 3. Okay, this side is ready for us. We're going to subtract x on both sides here. So we have 8 equals 1x minus 3. Add the 3 to both sides, we get 11 equals 1x, or 11 equals x. So that one is done. On this side, we're going to add the 2x to both sides. That way we get 8 plus 3x equals 3. We're going to subtract the 8 from both sides, get 3x equals negative 5, and then divide the 3 from both sides and get x equals negative 5/3. Okay, so we have our two answers, either x equals 11 or x equals negative 5/3. Now we need to go back and check. So I use my original equation here. All I'm doing is plugging in 11 for x right here and negative 5/3 for x right here. So it's going to look something like this. Plugging in 11, we have 8 plus 11 is all in the absolute value. 2 instead of times x, it's 2 times 11, and then subtract 3. I'm just going to do that side first, how about? So 8 plus 11 would be 19, so we have absolute value of 19. 2 times 11 is 22. 22 minus the 3 is, I was about to delete it, I'm just going to move it over. Absolute value of 19 is 19. So it says 19 equals 19. That is true. That's how we know that that one will check out. We know that this 11 is an actual answer. So we can go back and circle that one if we want. We say that one for sure works. X does equal 11. Now let's double check our other one. As we're working with this fraction, all we did was plug in negative 5/3 into x. 8 plus negative 5/3 is going to come out to be 19/3. All I did was change this into thirds and call it 24/3. Take away 5/3 is 19/3. Same thing over here. 2 times negative 5/3 is now negative 10/3. I'm subtracting 3. Now to help you with fractions, we're going to call this 9/3. 3/3 is the same as 9/3. Or sorry, 3, the whole number, is the same as 9/3. Negative 10/3 minus 9/3 comes out to be negative 19/3. Now notice, this one came out positive in the end because of the absolute value. This one ended up being negative. These are not actually equal to each other. Positive 19/3 does not equal negative 19/3, so this does not check out, meaning even though we solved everything correctly here, this is not an actual answer. So in this case, it actually did only have this one answer, just x equals 11. So we do need to make sure that we're double checking our answers, both of them at the end, just to make sure. So again, this is how you solve your absolute value equations. Something times an absolute value piece plus something on the outside equals something at the end. We're always trying to get the absolute value piece alone, then split it into two equations. One where, notice there's no more absolute value bars, just this part equals a positive thing, just this part equals a negative thing. Then you solve like normal, and of course, always double check your answer. Okay, that'll cover it for our first video, just on absolute value equations with one variable.